Hello everyone, this is the third part of the sniper shooting tutorial series. In this video I will show you how to make the bullet ricochet, penetrate the walls and leave decals on impact. First, let's create structure hit info, so we can pass more information about the bullet hit to the shootable object. This struct will contain raycast hit, vector with direction of the hit speed, reference to the bullet object, and boolean value that will indicate if the bullet should be destroyed after the impact. Now let's modify the onHit method so it will have the information about hit vector, and we will replace getComponent method with getComponents method so we can access not only one but all shootable object components that are on the game object we have hit. We have to create hit info object, assign all the information about the hit, and in the for each loop we will pass this info to all of the shootable objects calling onHit method. In the end we will check if destroy bullet variable has been assigned to true, and if so, we will destroy the bullet object. Now we have to pass property hit vector to our onHit method, which is vector between current bullet position and bullet position in the previous time step. We have to also modify shootable object abstract class to accept hit info as onHit method parameter instead of raycast hit object. We can see that now there are some errors showing in the Unity console window. We can select each of these errors and fix implementations of classes that inherits from shootable object class to also use reference to hit info struct. Inside enemy hit script, we can now use hit speed and hit direction variables to correctly apply forces to the ragdoll of the enemies we have hit, and we can make a parameter that will specify if we want to destroy the bullet object on the impact. Similarly, we have to modify other scripts that inherits from shootable object class. Now, all the warnings have disappeared, and everything works fine, except that now, when we shoot our opponent, he explodes into space. We will get to that in a moment, but now let's also test if we can disable destroying bullets on the hit with the walls. Let's test it. We can see that particles are instantiated on the impact with the wall, but the bullet is flying right through it and then hits the ground. But still, we haven't solved the flying enemies issue. So why this happens? Well, last time we assigned in the enemy hit script value of the impact force variable to 1000, and now when we are taking into account the bullet speed, which is also about 1000, the impact force is too big. We should change its value to 1, but we have this enemy hit component in every game object of the enemy that have a collider, so this is a lot of places to modify and we can miss some. So let's create the script that will find each enemy hit component in child game objects and assign correct values to each one. We will mark this script to be executed in the edit mode and add the fines to make update function only be executed in Unity editor. In the start, we will get every enemy hit component in the object children's. And then, in the loop, we will assign all the values correctly to each enemy hit component. Now let's assign proper values to the enemy manager script. We can see that enemy hit components have been modified properly. Let's check if this fixes our issue. Now enemy isn't flying anymore to the outer space, so we can assume that the issue has been fixed. Now we can allow the bullet to fly through the wall without being destroyed, but still we cannot change its speed or flight direction. So let's make a method Reinitialize inside the parabolic bullet class that will allow us to reset bullet start position, rotation and speed. We have to reassign bullet start position, start forward vector, bullet speed and also reset start time and is-initialize the boolean value. Now let's modify wall hit speed so it can absorb some of the bullet speed, but still allow bullet to fly to the other side. we will create speed absorption parameter and calculate new bullet speed. If the calculated speed will be smaller than 0 or the always destroy bullet variable will be set to true, the bullet should be destroyed. But otherwise, we will reinitialize the bullet with the position of the hit moved by a small offset into the wall so it won't hit the same wall again. Start forward direction will be set the same as the hit direction, and speed will be set to the new speed we have calculated. Let's test it. To visualize this better, I will increase the absorption value and make the wall transparent so we can see how far the bullet will fly. We can see that bullet now flies much closer if we hit the wall. Now let's separate particle spawning logic from wall hit logic so we can have more flexible system. We will create particles hit script and copy the code that is responsible for spawning particles from the wall hit script into the new one. Also, let's extract particle lifetime to parameter so we can easily modify it in the editor. We will also remove from wall hit the code responsible for spawning the particles. Now let's assign to every wall particles hit component and test it. We can see that nothing has changed, but now we can make spawning particles logic independent from wall hit logic, which will be handy later when doing Ricochet hit logic. But first let's make Decal hit script that will spawn sprites on the bullet impact. We need parameters like Decal object, which will be instantiated on the hit, max and min scale, and lifetime. Now we can instantiate Decal object in the hit point with a slight offset to the outside of the wall so it won't clip to the wall. We can set random rotation around the wall normal vector and set a random scale between min and max specified in the parameters. And destroy Decal after specified lifetime. I have prepared a simple glass decal. For it to work as a sprite, we have to change the texture type to sprite and select Alpha is Transparency checkbox. Now we can drag the sprite into our scene and create a prefab out of it. Now when we have created a decal prefab, let's assign it to the decal hit script and test if it works. We can see that it works perfectly and spawns decals with random rotation and scale. For me, they are even too large, so I will decrease a little bit max and min scale. Perfect. In the end, let's make a Ricochet hit script. It will have parameters like min speed, max angle, and max speed absorption. We will calculate the speed absorption based on the angle between the wall's surface and bullet hit direction vector. To calculate this angle, we can calculate the dot product of the wall normal vector and hit direction vector. Because both of these vectors have a magnitude of 1, the value of the dot product will be equal to the cosinus of the angle between them. To transform it into an angle, we can use Arcus cosinus, and we will convert angle from radians to more readable for us degrees. And lastly, we subtract this angle from 90 degrees, because we want the angle between hit direction and surface, and not the normal vector. For now, we will linearly interpolate between max speed absorption value when the angle is equal max angle and 0 when the angle is near to 0. The new speed will be calculated just by subtracting speed absorption from the hit speed. If calculated angle is greater than the max angle or speed is smaller than 0, then we will destroy the bullet. Otherwise, we will reinitialize it with the new speed and forward vector that we can calculate using built-in function vector3 reflect and passing as the arguments hit direction and wall normal. Now let's attach this script to another wall and test if it works. We can see that indeed this works, but let's further improve this script. The bullet speed on the Ricochet doesn't decrease linearly with the angle, but rather quadratically. We can use animation curves to specify in the editor how should this curve look like and adjust it to our likings. Now we can use method evaluate to get value of the curve in the specific point and multiply it by absorption multiplier value. Let's assign proper curve for our Ricochet script. The smaller the angle, the less we want the absorption to be. Now we can see that our bullets are ricocheting really close when we have a large angle of shooting, and really far when the angle is small. You can experiment with the curves and values and get the results you like. I hope this tutorial will help you develop your own awesome games and that you learned something useful. Thanks for watching and happy coding. Cheers!